We are going to just solve this quick problem looking for the discriminant and the number of real zeros. So what I'm going to do first is just look at the discriminant. And the discriminant is b squared minus 4ac. So here's our a, here's our b, here's c. So I have negative 4 squared minus 4 times negative 3 times negative 1. And that gives us 16. And we have negative 4 times negative 3, that's positive 12. And then minus 1, times negative 1. And that's going to be just a negative 12 again. We have 3 negative signs, so it's going to end up being negative. So my discriminant is 4. So this shows, because it's positive, I'm going to have 2 real zeros. I could also put 2 real roots or 2 real solutions. I could answer that those different ways. So now that we know that there's 4, I can go ahead and say, okay, that's one of mine that has 2 real roots. So I'm going to go ahead and find those zeros by using the quadratic formula. And you know that, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll just go ahead and plug that in. So that's finding 2 real zeros. This next problem, it's 4a squared plus 4a plus 1. I'm just going to have it set equal to f of x as of right now, because that's the function I want to look at. So if we find the discriminant for this one, we're going b squared minus 4ac. Here's our a, our b, our c. So 4 squared minus 4 times 1. And then we're going to get 16 minus 16, which is 0. So our discriminant is 0. And we know that if the discriminant is equal to 0, then there is 1 real 0. And going ahead to find the zeros, we'd have to set up the quadratic formula again. We'd have to do the quadratic formula. The last one I want to look at in standard form is negative 4x squared plus 5x minus 9 equals negative 6, just a little different. And in order for me to solve it, it has to be in standard form, even if I'm the discriminant. So I'm going to rewrite it. And if I add 6 over, I have negative 3 equals 0. Let's find the discriminant, spelling it wrong. There we go, so b squared minus 4ac, b squared, a, b, c. So b squared would be 5 squared, 25, minus 4 times negative 4 times negative 3. And I see 3 negative signs in here, so I know that I'm going to have a negative answer. It ends up being 48. So my discriminant is negative 23. And because it's negative, I know I'm going to have no real roots. And I'm going to have 2 imaginary roots. 4 zeros, 4 solutions. Remember, all those words are interchangeable. So 2 roots. So when we go ahead and solve for the zeros, we're going to still use the quadratic formula, setting that up. What we're going to realize is that our discriminant that's located under here, negative 23, when it comes out, we're actually going to have I square root of 23, right? And that's our imaginary part there. I want to look at 3 more problems. Problem 1, problem 3 that I have left here, those are in vertex form, so we can't necessarily find the discriminant when it's in vertex form. This, remember, we talked about something being in vertex form and in standard form, and that's this problem here. But what I'd like to do is just be able to find the number of real solutions when we can't use the discriminant. So if we're working here, set f of x equal to 0, as always. We'll bring 6 over to the other side, so 6 equals 2. X minus 5 squared, divide each side by 2, so 3 equals x minus 5 squared. Take the square root of each side, plus or minus square root of 3 equals x minus 5, and then we'll finally add the 5 over. So we can see that these solutions, 5 plus radical 3, 5 minus radical 3, those are numbers we can actually plot on the x-axis. So that means we have 2 real roots, or 2 real zeros, or 2 real solutions. Again, those 3 words are interchangeable for us. Number 2, I'm going to treat this like it's in vertex form because it's a lot easier than if we have to go ahead and put it in the quadratic formula. So if I bring 14 over to the other side, I'll have negative 14 equals x squared. When I take the square root, I have negative 14 equals x, plus or minus square root of radical 14 equals x. And in that case, I have a negative under the radical sign, and I can't have that. So recall that when we have a negative under there, we can take it out as the imaginary number I, because I is equal to the square root of negative 1. So we just kind of broke that up, and we'll keep the 14 under. So here are 2 zeros, I, like positive I square root of 14, and then negative I square root of 14. Those are 2, but those are 2 imaginary roots. All right, they're 2 factors of the function. It's just that I can't plot them on the x-axis, so that makes them not real. And I'll write that no real zeros. And then this last one, when I go ahead and bring the 6, oh, did I write the problem twice? I wrote the same problem twice. Let me erase that. What's this last one? It's negative x plus 2 squared. All right, so sometimes when you guys see this and there's nothing over there, setting it equal to 0 looks funny, but you're always setting the problem equal to 0. So equal to 0. There's a negative 1 out there, so we'll divide by negative 1. X plus 2 quantity squared, still equal to 0, and I divide. When I take the square root of each side, I get the plus and minus the square root of 0. Well, that's 0 no matter what way you look at it. So it ends up being, when we subtract the 2 over, that it's just x equals negative 2. And that's 1 real 0. And it makes sense because if we talk about the graph of this function, we know that the vertex is at negative 2, 0, negative 2, 0, and we know that it opens down. So it makes sense that the graph only crosses the x-axis or touches the x-axis once, so it's 1 real 0.